As we continue in the review, we're talking about integrals representing the area under a curve, and specifically the area between that curve and the x-axis. So if the graph is above the x-axis, you're going to have a positive area. If the graph is below the x-axis, you're going to get a negative area. And just like in this picture here, which is looking at the function y equals sine of x from 0 to 2 pi, you can see the positive area and the negative area would cancel each other out. So if you were to integrate from 0 to 2 pi, you would get a 0. If you want to find the total area, you would need to look at the absolute value of these individual areas. And to do that, you'd have to set up two integrals, one from 0 to pi and the second from pi to 2 pi. Find those two areas, take the absolute value of each, and you can find that the total area would be 4. For the first example, we're not going to have to worry about a positive and negative area with something being above and something else being below the x-axis, but we are asked to find the area of the shaded region. Now the curve here, the function y plus cosine x, is this blue line. Typically when you'd find the area, it'd be the area under that function, but here we're asked to find the shaded area. And this is the area between y equals 2 and y equals 1 plus cosine x. So what we're going to do here is we're going to subtract these two functions. So we're looking at the integral from x equals 0 to x equals pi. And again, this time we're finding the area between these two functions, so we're just going to subtract the top minus the bottom function. So it's 2 minus 1 plus cosine x. When you take 2 minus 1 plus cosine x, 2 minus 1 is going to give you a 1. Then that negative to the cosine x, so it'll be 1 minus cosine x. We're going to go ahead and integrate this. When you integrate the 1, it simply becomes an x. And we talked about this before. When you integrate cosine x, you're going to get sine x. And we're going to evaluate these at pi and at 0. So at pi, we have pi minus sine pi, then 0 minus sine of 0. Sine of pi, and in the picture at the top of this page, it's hidden on my screen right now, but the picture at the top of the page, you'll see that sine of pi and sine of 0 are both 0. So what you really have here is pi minus 0 minus 0 plus 0. So your answer here is pi. That area is equal to pi. Now, sometimes your function is going to give you areas that are both above and below the x-axis, and that is what we have here. We actually have 3 different regions, the 2 green ones being below the x-axis, the blue one is above, of course. So we're going to end up looking at integrating this among 3 intervals. We're going to look at the interval from -3 to -2, that's going to be the first green area. Then -2 to 0, that's the blue area. And then finally from 0 to +2, that's going to be the second green area. Before we get to that, I want to just integrate this function. Let's go ahead and just get what that is going to look like. So if I integrate -x squared minus 2x dx, so I don't have an upper or lower bound here, just going to look at what this ends up being. The negative will just come in front of our answer here. If we look at x squared, it's going to be x cubed over 3. Then minus 2x, if I write the minus 2, when you integrate x, it's x squared over 2. So these would cancel. So you're left with negative x cubed over 3 minus x squared. And if it's an indefinite integral, you'd have your plus c. But we're going to be focusing on this part here in just a minute. So like I said before, we're looking at 3 separate intervals. We're going to integrate that function from -3 to -2, -2 to 0, and then 0 to 2. So starting with -3 to -2, when you integrate, we already know what the answer is because we just did that, negative x cubed over 3 minus x squared, and I need to evaluate that at -3 and -2. So starting with the -2, -2 cubed is -8, -8, I'm going to get a positive, excuse me, 8/3, minus -2 squared is 4. Now substituting in -3 for x, -3 cubed is -27. The opposite of that is going to be positive 27. So we have 27 over 3 minus -3 squared is 9, so minus 9. Now note in that second set of parentheses here, 27 over 3 is 9, and 9 minus 9 is 0, so this whole thing becomes a 0. So we just need to focus here. We have 8/3 minus 4, so that's going to be 8/3 minus 12/3, or -4/3. So the area here, this first green area, is -4/3. Now we're going to repeat the process 2 more times. We're looking at now the interval from -2 to 0, and we'll repeat the process. So this time we're going to be evaluating -x cubed over 3 minus x squared from -2 to 0. Plugging in the 0 first, you get 0 cubed over 3, which is 0 minus 0 squared. So it's just going to be 0. Minus, when you plug in the -2 for x, we already worked that out. We know that that's going to be -4/3, so you have 0 minus -4/3. That should be a 4. And that's going to be a positive 4/3. So the blue area here is positive 4/3. So now we're just left with the third area, the final area, which goes from 0 to positive 2. And one last time, we're going to evaluate this. So this time we put in a 2, positive 2 for x. We end up with -8/3 minus 4. And when we put in the 0 for x, like before, it's just a 0. So it would be minus 0, doesn't impact anything. So in this case, we have -8/3 minus 12/3. So the area is -20/3. So the total area, you're just going to add the absolute values of each of these three individual areas together. You get 4/3, it's the absolute value of -4/3, plus 4/3 for that blue region, and then the absolute value of -20/3, +20/3. Add those together and your total area is 28/3.